All right, so today what we're going to do is we're going to continue our 2.3 lesson where we left off with the last time, which was synthetic and long division. And we're going to talk about two new things. Okay, the first thing that we're going to talk about is what's known as complete factorization. Okay, and in complete factorization, I want you to kind of think about the word factor. So that means that it has been completely factored into its smallest binomials possible. So they're all in parentheses. It's going to be x plus a number. It'll be x minus a number, and all your exponents should be to the power of 1. Okay, so let's work on our first example. So let's copy this down. So I gave you a function, and so f of x is equal to, and here is our function. So 3x squared plus 2x minus 19x plus 6. And I told you a factor, so it's x plus 3. So what this says is that based on this information, we're going to do a complete factorization of this problem. I already know that this factor is going to work, right? If it doesn't work, then we have made a mistake somewhere in our calculations. Okay, and what we can do is we can get extra practice with long division if you want to do that, or if you notice all your factors are going to be an x plus number, x minus number, we can use their synthetic division. So that's what I'm going to do. I'm going to use synthetic division. So if I set my factor equal to 0 and I solved, remember I would get the negative 3. So I draw this L shape and put the negative 3 on the outside. Then I'm just going to take my coefficients, include the negative or positive sign. So I have a 3, positive 2, negative 19, positive 6. And again, I'm hoping that 0 is right there unless I made a mistake. All right, what do? We bring down 3. And then it's a vertical pattern, diagonal patterns, we multiply. So this will give you a negative 9. Vertical pattern, we add them together. So negative 9 plus 2 is negative 7. Multiply those two numbers together. I get a positive 21. Negative 19 plus 21 gives me a positive 2. 2 times a negative 3 gives me negative 6. And look at that. I got a remainder of 0. So this is a factor of our polynomial function written above, right? So if I asked you to rewrite this problem now with our new coefficients, right, we'd have 3x, now 1 less than cubed is squared, minus 7x and plus 2, right? So that is a trinomial. Now we don't have to use synthetic division for a trinomial, right? You can just factor it on your own. So I'm going to go ahead and I'm going to multiply 3 times 2, give you 6 on the top. Negative 7 goes on the bottom. So the two numbers that multiply to 6 but add to a negative 7 will be negative 6 and negative 1. Again, I'm going to divide by my a value. So negative 1 over positive 3. I can't simplify that fraction. This fraction I can. Gives me a negative 2 over 1. So this trinomial can be factored into the following two binomials. Bottoms up, bottom number gets written first, right? So since we have a 1, we don't have to really put the 1 there. And here, the bottom up, 3x minus 1. Now, if these two binomials multiply to give us this, what are the three binomials that would multiply to give you the complete factorization for this problem? That would be your original x plus 3. And then these two new binomials that we found, x minus 2 and 3x minus 1. So right here is your complete factorization. Complete factorization for this problem. So again, notice no coefficients not coefficients, no exponents attached to your x. You do have a coefficient in front of your x, which is fine. We can leave that there. Okay, and again, if I multiply these binomials together, I will get that binomial. So if you ever see the word complete factorization in your homework, that's what it's looking for. Okay, so let's move down to example number 2. So here's my second example. So again, I have a higher degree of the power of 4. Okay, and take a moment, go back to example number 1. I want you to notice that the highest power is a power of 3. Notice that you have 3 binomials. So again, use your common sense. If you have a power of 4, how many binomials do you think you're going to have? 4, correct. All right, so notice that I gave you 2 binomials this time. Both of these binomials are going to work. So you're going to pick one, and you're going to use it for the first one, and then once you've simplified it down, then you're going to use the second one. Then you'll have a trinomial, which will be wonderful, and then we can find out the rest of our complete factorization. Okay, so I'm going to go ahead and just use the first one that I see, negative x plus 2. So I'm going to set that equal to 0. I'm going to get negative 2. All right, and then use my coefficients. So 8, negative 14, negative 71, minus 10, positive 24. So I have to extend that out just a little bit more. So bring down the 8, multiply 8 by negative 2, so I get negative 16. Add those two numbers together. Negative 30, multiply those two numbers together. 60, add these two, I got negative 11. That will be 22. 22 and a negative 10 should be 12. And negative 24. Got a remainder of 0. Okay, so this new polynomial will be 8x cubed minus 30x squared minus 11x plus 12. And then we're going to do the process all over again. Now, we already know that this was our one factor, so we've already done that, put a little check mark. So now what I'm going to do is I'm going to use these new coefficients and my new factor. So if I set that equal to 0, I get 4. And 8, negative 30, 11, negative 11, and 12. So 8, negative 30, negative 11, and 12. Okay, bring down the 8. Gives you a 32, positive 2. And that gives you 8, negative 3, negative 12, 0. Yay! So what do you get? You get 8x cubed. Oh, sorry, not 8x cubed. 8x squared, my fault, plus 2x. And minus 3. So now we've used that factor. So the whole process of using a different factor and using these new coefficient numbers is you want to keep simplifying our polynomial by breaking it down a little bit by a little bit. If you used the original numbers one more time, you would still get 0 as a result. You would just obviously get different numbers, and you're going to get stuck always at a cube level. So that's why you want to take it down to using the new coefficients. Okay, so this one looks like an easy trinomial to factor. So 8 times negative 3 gives you negative 24 on the top, positive 2 on the bottom. So the two numbers I multiply, I believe, are 6 and 4, making the 4 negative. Divide by 8. Right. Both of these can be simplified. So negative 4 over 8 gives you a negative 1/2. And let's see, 2 goes into both the top and bottom, leaving you with 3/4, right? So the complete factorization, I call it CF, right, of f of x, right? This will be f of x is equal to, use your original factors, x plus 2, x minus 4. Then we're going to use our new factors. So 4x plus 3 and 2x minus 1. So that's our complete factorization. If I asked you to tell me what your zeros were for this problem, right? Well, you already used one of your zeros, right? It was a negative 2, because again, a 0 means that I've set this equation equal to 0. I've taken away the f of x, and I solved for your binomials. So if I solve for this binomial, you get negative 2. Solve for that binomial, you get a positive 4. Solve for this binomial, you're going to get the opposite fraction that we see there. Solve for this binomial, you get the opposite fraction as well. Again, notice 4 binomials, power of 4. 4 zeros, power of 4, right? So everything is connected to your exponents, right? So that's your complete factorization. So if you see problems on your homework that ask you for complete factorization, that's the answer that I'm looking for. If I ask you for what are my zeros, this would be your answer. You just set your binomials equal to 0. Okay? Now, you might be wondering, well, where do these factors actually come from? Where do these zeros come from, right? I gave you the two factors in example 2. I gave you the factor in example 1. So there is a test, all right? You might need to pause this video and copy this down. It is called the rational zero test. So what is a rational number, right? Your rational numbers are all your integers, right? Positive and negative, and then all your fractions, okay? And it's a test because you're going to have to try multiple answers. So again, you've seen this polynomial in the last video, okay? These are just your coefficients of your variables, and your exponents start with your highest degree and then go down by 1 each and every time. Remember, a of n cannot equal 0 because then the highest degree is not actually what you see. Okay, so basically what this says is that if it has integer coefficients, so no fractions here, integers, okay? So again, look at these other two examples. Notice that 3, 2, negative 19, 6. These are your integers, right? We can get fractions that are 0, we can get fractions that are part of our zeros answered, but notice that we do not write fractions in binomials, okay? So going back to this problem, so if we have integer coefficients, every rational zero of this function f can take this form, plus or minus p over q, okay? Now, if you read a little bit further, we can figure out what p and q are. P and q are factors, and p is the factor of a sub naught, right? Which is your constant term, okay? And it is a plus or minus. I put that in the beginning so that we don't have to really worry if that's a positive or a negative number. We'll just always have a plus or minus in front of there. And your q is the factor of a of n, right? So that's your leading coefficient. I think I spelled that wrong. That's okay. Okay, so all you're doing is you're setting up a fraction in order to solve. Okay, so these are all your rational zeros, and if you test out all these zeros and you didn't get one that worked, meaning you did not get one with a remainder of 0, then your problem, your polynomial function does not have a rational zero. So let's try our first example. So we're going to list all possible rational zeros. I do not need you to solve for all possible rational zeros. We're just listing them. This is the easy one. All right, so notice that we have power 5, power 4, 3, 2, 1, then your constant term. All right, so I said your p-value is your constant term, right? So even though it's a negative, let's just work with it as just a positive 2 because the negative will come back into play. So there's your p, right? And think about your factors, meaning what numbers do you have to add? What numbers do you multiply in order to get 2? You would say a positive 1 and a positive 2. Okay, so there's no other numbers, right, integers, that we can multiply to get to 2. So let's go to 4. So q is equal to 4. Again, ask yourself what numbers can you multiply to get to 4. That would be 1 times 4, so 1 and 4, and then 2 times 2. So I can just write the 2 out once. Okay, so if you included the negative 2, so just you don't have to write this down, but if you said p was equal to negative 2, right, you would think negative 1 and a positive 2 can multiply, and then a positive 1 and a negative 2. So notice that there's a lot of numbers I have to worry about, and then 4, right, positive 1, negative 4, negative 1, positive 4. So there's a lot of different ways, there's a lot more numbers that you have to worry about writing out, and we'll address that in a second. So how to list all your possible rational zeros. So possible rational zeros, right? P's and Q's, right? Plus or minus. You're going to take every P divided by every Q. Put a little plus or minus in front of it. So let's take our 1. So 1 divided by 1, simplify it, gives you 1. And let's take our 2. So 2 divided by 1, so plus or minus 2. Boom. There's no more numbers on the top that I have to divide by 1, so I move on to the next number. So 1 divided by 4, so plus or minus 1/4. And I'll move to the 2, so 2 divided by 4, so plus or minus 2/4. All right, so far we've never seen any of these numbers before. I could simplify 2/4 and it would give you 1/2, which is fine. And then go on to the next number. So 1 divided by 2 plus or minus 1/2. Now, notice that you already have a plus or minus 1/2. So what we call this is we call this an extra P and Q. Right? Does not mean that this for sure is an answer. It just means that it's appeared more than once. So you don't have to worry about writing it down more than once. And then let's try 2/2. So plus or minus 2/2. Now think about this. 2/2 gives you 1. So we already have that. Again, it's an extra P's and Q. So we can go ahead and we can get rid of it. Right? So that means there are 1, 2, 3, 4, 5, 6, 7, 8. 8 possible rational zeros for this polynomial, right? So if I wanted to know what my rational zeros were, right, I'd have to plug those in, which we'll do in the next problem. Okay, now what happens if you actually left these numbers out the way they were? And so then I said, 2 and a -2 and then a +2 and a negative. You get the idea, right? You're going to get the same answers here, right? So I'll draw a little box. So -1 divided by 1 gives you a -1. And -1 divided by, -1 divided by -4 gives you a 1/4, right? -1 divided by -1 gives you a +1. Notice -1, +1. That's where that plus or minus comes into play. -1 divided by 4 gives you a -1/4, -1/2, +1/2. Then we move over 2 and 1, so +2. That gives you a -1/2. Notice we already have a -1/2, so I get to eliminate it. So you can write it out, but just notice that we have a whole lot more numbers that could potentially repeat, and this will give you the same idea, and it's just a little faster method. Okay, so I'm not going to continue with the negative to save a little bit of time. All right, so I want you guys to try this problem, find all the real zeros of the polynomial function, kind of just like what we did in that last example. So pause it, try it, and then come back. All right, so if we're back, we're just double checking all of our work. So our P, our constant term right here, is 30. And so I like to put all my numbers in order. So it'll be 1, 2, 3, 5, 6, I think 10, 15, and 30. So 1 times 30, 2 times 15, 3 times 10, 5 times 6. Perfect. And the great thing about Q as 1, it's so easy. So this was a pretty easy problem. So all your possible P's and Q's should have been plus or minus, and then all of those numbers, right? Because 1 divided by 1 is 1, plus or minus 2, plus or minus 3, plus or minus 5, plus or minus 6, plus or minus 10, sorry, plus or minus 15, plus or minus 30. Fantastic. Now, let's continue with example number 2. So I just wanted you to find all the possible zeros, right? So now it's actually asking you to find all of the real zeros of this polynomial function, okay? And what we're going to do is we're going to use these zeros to kind of help us, okay? These are all the possible answers that you have, okay? And I want to see which ones that you guys try first. You're going to, after lots and lots of practice, you will hopefully know kind of which ones to use, okay? My rule of thumb, is always I want to start with the smaller numbers and kind of work my way to the bigger numbers. So the chances of like the 30, the 15, or the 10 working are usually a little bit slimmer than like a 1, 2, or 3, okay? Now, because I don't want this video to go on forever, right, I'm going to pick the correct number to try, okay? So I'm going to pick 6, right? So I'm going to pick 6, use all of these numbers. So this will be 1, -1, -29, -1, -30. So I'm going to use my synthetic division one more time, right? So if you didn't understand it, by the end of this lesson, you hopefully will have a better understanding. So bring down the 1, I got 6, and 6, multiply that, 5, so 30, and 1, so 6, 25, 30, and 0. I just realized that I made a mistake. That should not be a 6 there. That should be a 1, right? So again, notice that 6 worked out. So far, 6 is a 0, okay? So the next number that you want to try is you want to try 6 again, okay? Because remember when we were doing the sketching polynomials, remember that we can have a 0 repeated once, which goes right through the graph, a 0 repeated twice, which means that there's a bounce at our graph, or you can try it 3 times, which means that there's a cubic through that graph, right? So we definitely want to try it one more time, right? So always recommend trying it one more time. So let's try 6 one more time. So I use these new numbers, so 1, 5, 1, 5. So bring down the 1, and I get 6, and I get 11, and then I get 66. Now, I'm going to stop here because by the time I add these numbers and I multiply by 6, I'm never going to get negative 5 here. So what do I know? I know it does not work for the second time, but it worked the first time. So it just means that it's repeated once. 6 is not repeated twice, so we're okay. So what do? We pick a new number, right? And again, if you want to pause the video and try a couple numbers on your own, feel free. But I'm going to tell you what the correct number is. So close your eyes or pause it right now. Great. So if you tried the number negative 5, you were correct. And if you didn't, no worries. So bring down the 1. I got negative 5. That gives me 0, 0. I love when it gives me 0. And negative 5, boom, worked out. So I know that's great. So if this was your cube, right, then this is your x squareds, right? So it went down from 4, so this will be 3 to 2. So x squared plus no x's plus 1 is equal to 0. And I want to continue solving this problem to the best of my ability. Remember, I'm trying to find real zeros. We haven't really talked about imaginary numbers yet, so don't worry about imaginary numbers. So if I set this equal to 0, solve for, I get negative 1. There is no real number that I can plug in for x that I can square to give me negative 1. So don't worry about it right now. So when we come back to our problem, real zeros, we only have 2, which is fine. 6 and negative 5. Sometimes we have more, right? Sometimes we could potentially have, less, right? It all depends. Okay. So let's go ahead and try example 3. So again, example 3, we're going to find all zeros. So find all real zeros. Okay. Pause it along the way. Try to find your P's and Q's. Check with it. Then pause it again. Try some zeros. Work it out. Okay. So if you have unpaused this video, you are trying to look for your P's and Q's. So your P was 5, and all the factors of 5 are just 1 and 5. Your Q was 3, and all your factors are 1 and 3. So that means all of your possible rational roots, or zeros, will be plus or minus 1, plus or minus 4, plus or minus a third, plus or minus 5/3. All right. So we have 2, 4, 6, 8 numbers to try. So let's try 1, see what works. So I'm going to try negative 1 to be exact. So 3, negative 10, negative 24, negative 6, positive 5. So let's bring down the 3, negative 13, positive 13. So that should give you a negative 11. Positive 11, 5, negative 5, 0. That worked out. Congratulations. You found your first real zero. Okay, I'm going to try negative 1 one more time because what did I tell you in the last problem? We should. So negative 1 one more time. So 3, negative 13, negative 11, and 5. So I got 3, negative 3, negative 16, positive 16, 5, negative 5, and 0. Well, isn't that a coinky dink? It worked out. I knew it was going to work out, right? So again, this went through a cube. This one is your squared. So let's take this problem. 3x squared minus 16 x plus 5, right? We're solving for that, so let's set it equal to 0. And again, let's go ahead and factor it, see if it's factorable, which hopefully it should be if I did everything correctly. This problem will be. And negative 15, negative 1, divide by 3, divide by 3. So that will give you a negative 5 over 1. This just leaves us negative 1/3. So I have binomials x minus 5, 3x minus 1. So if I set that binomial equal to 0, I get x is equal to 5. Notice that 5 is on our list of possible P's and Q's. If it was not on our list of possible P's and Q's, we did something wrong. Okay, and then if I set this one equal to it, I get a positive 1/3. Again, notice positive 1/3 was also on our rational list of zeros, right? So how many zeros do I actually have? I have 4. So I have 4 real zeros. What are they? Negative 1, negative 1, 5, and 1/3. What's actually happening at the negative 1 if we graphed it? There would be a bounce, right? Nothing else is happening at the 5 or the 1/3. It's just a fraction, okay? Or they're just going straight through, okay? So again, advice. Find all your P's and Q's, right? P is your constant term. Q is the leading coefficient. You're going to love it when it's 1. Sometimes it is, sometimes it's not. Then you want to try some of your numbers. Sometimes it's going to be a fraction, okay? But you're going to set it up exactly the same way, all right? Again, if you have any questions or concerns, please email me, and I will get back to you, especially if you tell me what answer you got. And I can kind of work through the problem and kind of figure out where you might have made your mistake. You can also take a photo of your homework and email it back to me. All right? Great.